Hello Explorer family, I'm making a video explaining how to multiply using the area model and the partial products method. I will start with the area model. The area model is great for those who need to section off and visualize the multiplication process. So, the equation that I've shown is reflective of our standard, which goes up to 3-digit by 2-digit multiplication. So, the parts of our multiplication is going to be two factors and a product, of course. We have our two factors, one being the multiplicand and the other being the multiplier. This is the number that we start off with, and this is the number that is going to be multiplying that number, making it larger, and we are going to work towards our product. So, this is our setup for our area model. This is our area box, and we're going to fill it up using our two factors here. Because our first number has 3 digits, we're going to break it up into expanded form, and we will need 3 different sections for each digit. So we have 300, we have 20 in the tens place, and we have 8 in the ones place. For 53, we're going to have 50 and 3 for the ones place. This is our current setup. So in each box, we're going to multiply the corresponding numbers. So in this box, it will be 300 times 50, 20 times 50, 8 times 50. In this one, 300 times 3, 20 times 3, and 8 times 3, both matching up with the corresponding numbers on the corresponding boxes. So we are going to use, to make this multiplication easier, the multiply by hiding the zeros method Mr. McIntyre has taught our students. So we have 3 zeros here. We can hide all 3 of these zeros to make this multiplication easier. So now we have 3 times 5, which would be 15. If we were to bring these zeros back, add them to the rear of our number, we get 15,000. The same with this one. Hide the zeros. 2 times 5 is 10. And then we bring the zeros back. We have 1,000. We have, hide the 0, 8 times 5, which is 40. Bring the 0 back, 400. Hide the zeros. 3 times 3 is 9. Bring the zeros back. Hide the 0. 2 times 3 is 6. We have 60. And then a nice simple one, 8 times 3 is 24. All of these are what we would call partial products. Partial products. So we need to take our parts, product parts, and bring them together. So we have 15,000, 1,000, 400, 900, 60, and 24. And add them together. Make sure that all of your place values add up nice and smoothly. If you need to, draw a line, making sure they stay sectioned off. Please do that. But for our use right now, is not necessary. So 0 plus 0 plus 0 plus 0 plus 0 plus 4, we have 4. We're going to just add straight down. 0 plus 0 plus 0 plus 0 plus 6 plus 2 is 8. We have 0 plus 0 plus 4 plus 9 is 13. Bring that 3 down, carry the 1. 1 plus 5 plus 1 is 7. And then a 1 plus nothing is 1. So we end up with a product of 17,384. And that's how we use the area model. All right, now let's use the partial products method. This method is useful for those who understand the structure of a multiplication equation and want to solve using a quicker method. Yes, it is not as quick as using a regular vertical equation like this, but by using the partial products method, you can more easily catch any mistakes possibly made. So let's show you the way we do this. First steps is to break this into expanded form. So we would take, just like in the area model, this 328 and bring it up into 300 plus 20 plus 8. For the 53, we would break it up into 50 plus 3. Now, we would take this and bring a line straight down so we have some room to write these multiplication problems. So, our first set, we will make sure that we multiply this number by each of these, resulting in 50 times 300, 50 times 20, 50 times 8. We would make sure that we do the same with our other value and make sure it is multiplied by each value of the other number as well, resulting in 3 times 300, 3 times 20, and 3 times 8. That makes sure each part of each factor is multiplying with each other, resulting in partial products that we can add together later. Keyword partial products. Just like from the area model and its namesake, these will result in products, the answer to a multiplication problem, and give us the parts that we would add back together to get the whole product. So just like we did before, it's the same exact number. So I'm going to fly through this multiplication. But remember, to make it easier, you can always hide those zeros, bring them back to make everything a lot quicker. So we have 50 times 300. That's going to be 15,000. 50 times 20. That's going to be 1,000. 50 times 8. 400. 3 times 300. 900. 3 times 20 is going to be 60. 3 times 8. 24. And just like in the area model, we'll take all these partial products, add them up, so we can get the whole product. Yeah, 4 here, nice and quick. 13, bring that back. 3 down, 1 up. 7 and 1, resulting in 384, and that's how we would do the partial product. It's a little cleaner. This is a nice step by step so you can catch how you multiply, and if you need be, if you get something wrong, you can easily go back through these steps to catch which mistake you made. All right, let's dive into division. We will practice division using the area model and partial quotient methods. We will start with the area model just as with division. Again, the area model method is great for viewing the steps in an organized manner. The standard for division expects our learners to be able to divide up to 4-digit by 2-digit numbers. The parts of a division equation are the dividend, the divisor, and the quotient. The dividend is the number being divided. The divisor is the action number, the number doing the dividing, telling the dividend what number groups it needs to be broken up into. Our first steps are going to be a little different with the area model with division because we have to do some pre-prep. First, we need to find some potential partial quotients. We can do that as simple as being able to understand that 38 times 1 is 38. In doing that, we can know that 38 times 10, having that disappearing 0, will get us 380. We've practiced this in class. Our students should be fairly well managed in doing this. 38 times 2 is going to be 76 because we know that 38 times 20 is going to be 760. And we're just looking for these big numbers, partial quotients, to let us fill in the gaps later on in our next steps. 38 times 3, we can just add these two numbers together, the 1 and the 2, to get 114, because 38 times 3 is 114. We know that 38 times 30 equals 1,140. Now we can go ahead and stop here. If we need any more numbers, we can always come back to this step, but this is always a good stopping point to start off our next step with. So in the multiplication, it's good to know the different parts of the multiplication problem, but because factors in multiplication are interchangeable, it's not as important as in division, where these have to be in the order that they are for it to work. So we know that our dividend needs to go in this box. Beginning number, that's the number we need to break up. Our divisor is going to go on the outside of this box. We're breaking that up by a certain amount. And from there, we can continue. So, what of these numbers can we take away from our dividend to start us off with? We always want to try and take away as large a chunk as possible. Because of that, our largest number is this 1,140. So we're going to go ahead and add that in right here. And we're going to subtract. Because we added that number, we need to go ahead and add our partial quotient. Remember, we had our partial products. Now we have our partial quotients. So in this case, our partial quotient is going to be 30. So 1,594 subtract 1,140 is going to be 4540, 454. We need to take that number and put it into our next box and be able to take away from that. We can see that our next number would be 380. That's what's closest. That's what we're going to put in. And that's going to give the partial quotient 10. We use this and this. So again, we subtract. We have 4 minus 0, which is 4. And right here, we can't really do 5 minus 8. So we're going to borrow from our neighbor, turning that into a 3 and this into a 15. This 5 into a 15. 15 minus 8 is going to be 7. 3 minus 3 is going to be 0, leaving us with 74. Now, 38 can still go into this number, so we're going to move that on up to the next box. Now we can see what our next selection is going to be. All of these numbers are going to be too large. This one's close, but it's still above our 74. So we're going to just use 38, which is going to give us our partial quotient of 1. We're going to put 38 down here and subtract. Again, we have to borrow from our neighbor, so this 7 is going to become a 6, and this 4 is going to become a 1, so we're able to subtract 8 from it. So 14 subtract 8 is going to be 6, and 6 subtract 3 is going to be 3. Now, 38 cannot go into 36, so this is going to be our remainder. So, our next steps, just like everything else, we have to add up our partial quotient to get our full quotient. Very easy. 30 plus 10 plus 1 is going to be 41. And we're going to have our remainder of 36. And that's how we would use the area model for division. Okay, let's continue with division using the partial quotient method. Just as with the partial product method with the multiplication, this method requires a bit more understanding of division, but is quicker than the area model method. So, just as with any other division problem, we need to know that our dividend and our divisor are ready to go. As we set up, we're going to be looking very similar to a regular long division problem. But a bunch of very smart mathematicians decided to make long division even longer. So we have a few steps before we get started here. Again, we need to have a little bit of setup to start off with, understanding some possible partial quotients that we're going to be using in the upcoming equation, just like the problem before. we have 31 times 1 equals, 38 times 1 equals 38. Therefore, 38 times 10 equals 380. Continued with 38 times 2, 38 times 20, 38 times 3, 38 times 30. Just so we have a full understanding and we can be prepared when we get to our next steps. So, again, we're going to set up our problem. It looks just like long division, but we have some things set up to fit in later on. Again, with the partial quotient method, we will be subtracting down just like with the area model method, so be prepared for that. And we're going to just start just like we did before by trying to find the largest number to subtract from, which we see is 1140 and 30. So we would put our 30 here and our 140 here. And we would just subtract down. We would get 4, 5, 4, and 0 here. And now we need to subtract down from this number. That would be 380 right here. So we would put our 10, our partial product of 10 right here, and 380 right here. Subtracting down, we would get 4. We would take away from our neighbor, get 15, subtract 8, which is 7, and then 3 subtract 3 is 0, ending with 74, just like our last problem. And then we have our 38 times 1 equals 38. We would go here and subtract, and that would leave us with 36, just like before. And that would end up being our remainder. As you can see, I blew through this, making it seem fairly easy, but again, you can make mistakes. But the beautiful thing about just like partial products, partial quotients, you can always easily go back and find where you made a mistake so you can backtrack and correct yourself. So, just like before, we would add our partial quotients together to find our final quotient answer, which will be 41 with that remainder of 36.